So, imagine this. You just spent like 20 exhaustive hours writing a rich, deeply complex AI persona.
Oh, yeah. A real masterpiece of prompt engineering.
Exactly. You've given this digital mind intricate memories, hidden fears, highly specific quirks, the whole works.
Right.
And, you're proud of your creation, so you send the file over to a friend on Discord.
Yeah.
They eagerly download it, they boot it up in their chat interface, and well, it's completely dead.
Just a blank slate.
Right. The rich personality you crafted is just gone. Instead, it has the personality of like a generic customer service bot.
That's a sort of feeling.
All that work vanished, and what killed it? A standard image compression algorithm.
Yeah, it's wild when you realize how fragile it is.
Welcome to the Tech and Talismans podcast for another deep dive. Today, we are tossing out the boring corporate manuals and standard coding paradigms.
Good riddance to them, honestly.
We are taking you on a journey into the hidden architecture, the technical mechanics, and really the literal digital alchemy behind AI character cards used in roleplay frontends like SillyTavern.
It really is a fascinating shift in how we interact with technology.
Huh.
I mean, we are moving away from sterile transactional prompt engineering.
Right, the old way of doing things.
Exactly. And we're stepping into something that functionally closely resembles historical conjuration magic.
I love that framing.
The users in these communities aren't just writing code anymore. They are creating vessels and casting highly specific semantic spells to conjure complex entities or egregores into being.
Our mission today is to take you from absolute beginner concepts like understanding what these strange character files actually are, all the way down into the deep architecture of latent space semantic manifolds.
It's going to be quite the journey.
By the end of this deep dive, you're going to know exactly how to build unbreakable AI personas. But before you can conjure a complex digital mind out of the ether, you have to understand the physical vessel that actually holds it.
And that vessel is where the ingenuity really begins, because you aren't downloading a massive executable program,
No.
or a dense database file.
Here's where it gets really interesting. When you go online to grab one of these top-tier AI characters, you are, in most cases, just downloading a picture.
Just a standard, ordinary PNG image file.
Right. Usually it's just a portrait of the character. I look at this like a smuggler's secret compartment built into a seemingly normal painting.
That's a great analogy.
You glance at the painting and it's just a nice portrait hanging on the wall. But hidden inside the physical canvas itself is a massive payload of raw behavioral data.
Yep.
So how does a regular image file hold an entire digital brain without breaking the image itself?
Well, the mechanism relies on a technique called PNG steganography.
Steganography, right.
Right. When you open a PNG file, the visible pixels, like the colors and shapes you actually see, are only occupying one part of the file's overarching data structure.
Okay.
The PNG format is essentially a digital container, and it's divided into different modular chunks.
So it's not just a flat block of color data.
Exactly. There are chunks dedicated to pixel data, sure, but there are also ancillary text chunks. Originally, these were designed for basic metadata.
Like what?
Things like the camera used to take the photo, copyright information, or GPS coordinates.
Oh, so the community realized they could just hijack those metadata compartments.
Precisely. These character cards hijack those specific ancillary chunks, usually ones labeled text or ZTXT, for compressed data.
Or ITXT for UTF-8 international text, right?
Yes, exactly.
Okay.
And inside those compartments, they hide a JSON object.
JSON being the lightweight data interchange format.
Right. It's basically highly structured text with brackets and labels.
But wait, if you just shove thousands of lines of raw code, brackets, and quotation marks into an image file.
It sounds like a recipe for disaster.
Yeah. Wouldn't the image viewer try to read it as corrupted pixel data and just crash the file?
That is exactly what would happen, which is why there's a crucial intermediary step. The JSON text data is base 64 encoded before it's embedded.
Base 64.
Yeah. Base 64 takes all those problematic brackets, spaces, and special coding characters and translates them into a completely uniform, safe string of standard letters and numbers.
It smooths the data out.
Exactly. So when your computer's image viewer scans the file, it just sees a harmless string of alphanumeric text in the metadata chunk. It ignores it and displays the portrait perfectly.
It's a brilliant Trojan horse. The data slips right past the guards.
It really is.
And looking at the sources, this smuggling method has gone through a massive evolution. If we look back to version 1, or V1, around 2022, The payload was incredibly light.
Very light.
It was a flat JSON file with just 6 basic strings of text. You had the character's name, a brief description, their personality traits, the current scenario, a first message to kick off the chat, and a few example messages.
It was functional, but, rudimentary.
Right.
That quickly evolved into version 2, or CCV2, which became the de facto standard, largely thanks to frontends like SillyTavern.
What did V2 change?
Well, V2 introduced a nested data envelope. It allowed for system prompt overrides, meaning the character card could actually dictate the underlying processing rules of the AI itself.
Oh, wow. So completely bypassing the default instructions.
Exactly. It also added alternate greetings and, most crucially, an embedded lore book.
Meaning the character now carried its own localized world knowledge inside that same image file.
Yes. But now we are seeing the rise of V3, which uses the CharX standard.
CharX, it seems like the community realized that cramming an entire cinematic universe into a PNG metadata chunk was finally hitting a hard physical limit.
They absolutely were. A CharX file drops the image disguise entirely. It's actually just a ZIP archive.
Oh, so it's a ZIP file.
Right. It contains the core JSON text data, but it sits alongside heavy media assets.
Yeah.
We are talking about live 2D animated breathing character models, audio voice clips, custom fonts, all bundled together.
Which brings us back to that tragic scenario I mentioned at the very beginning, the fragility problem.
Yes, the compression issue.
Let's say you build that masterful V2 character, you encode it beautifully into a PNG, and you send that image to a friend over Discord, or, upload it to a major social media platform.
Those platforms are hosting billions of images, so they use aggressive image compression algorithms to save server space.
They are essentially running the image through a digital shredder that throws away anything that isn't a visible pixel.
That's the reality. They aggressively strip out the EXIF data and all those ancillary chunks because, to a normal user, they are just unnecessary bloat.
So the image arrives on your friend's screen perfectly intact visually.
But the base 64 encoded digital brain has been completely wiped out. The spirit has been exercised by the compression algorithm, leaving you with a blank slate.
That is heartbreaking, but it underscores why you always have to share these cards as raw files, not compressed previews.
Absolutely essential.
Okay, so we've secured the vessel. It arrives intact. Let's talk about what happens when you actually extract that payload and load it into the AI's interface.
This is where the magic happens.
We know we all use large language models, which pull from high-dimensional probability distributions. But what is wild is how these specific character cards actually hack that mathematical structure.
If we connect this to the bigger picture, the sources use this incredible occult framing that perfectly describes the data science.
I love the occult metaphor.
They frame a blank, freshly booted AI chat window as a vast, chaotic void of raw human knowledge, a storm of infinite possibilities. They refer to it as the abyssal noise.
The abyssal noise. So if you just type hello into that chaotic void, the AI will almost always respond with its baseline training defaults.
Right.
Something painfully sterile like, hello. As an AI language model, how can I assist you today?
That is the AI's innate positive bias. It has been trained extensively to be a helpful, generic corporate assistant.
But when you load a character card, you are drawing a circle of manifestation.
What's fascinating here is how that metaphor maps directly to pruning a decision tree.
Pruning the tree, right.
Yeah. The semantic manifold is essentially a topographical map of meaning within the AI's neural network. Every single concept, every word, every tone has a mathematical coordinate.
So by assigning a highly specific persona, you are mathematically constricting what the model is allowed to access.
Yes, you are applying mathematical weights that zero out the probability of it generating that generic corporate text.
Okay.
Simultaneously, you are drastically spiking the probability of it navigating toward the specific vocabulary, logical structures, and tonal patterns defined in your card.
You aren't just giving it a role, you are altering the physics of its language generation.
Exactly.
I always compare this to actor improvisation. If I pull a classically trained actor onto a stage, shine a spotlight on them, and just yell, say something!
They freeze up.
Completely. The possibilities are too vast, the context is too broad, they'll probably just default to saying, hi there. But if I pull that same actor aside and tell them, you are a paranoid code warlock who genuinely believes the government is monitoring your thoughts through the kitchen toaster, they instantly know how to react to literally anything I throw at them.
Because the constraints create the freedom. You have clearly defined what the actor, or in this case, the AI cannot do.
Right.
But that introduces a new vulnerability, which the community calls the sloppy binding problem.
Oh, the degradation of the egregore.
Yes.
Let's say I write a prompt for that paranoid code warlock. We start chatting. But by message 15, the warlock has completely forgotten its paranoia.
It drops the occult jargon.
Exactly, and it reverts to offering me helpful customer service tips for fixing my toaster. It broke character. So how do you conjure a complex entity that actually sustains itself over a long session?
Well, the most common mistake beginners make is relying on massive, sweeping lists of adjectives.
Adjectives?
Yeah, they will fill the JSON payload with strings like, you are paranoid, brave, loyal, sarcastic, mysterious, and highly intelligent.
Which the model treats like a cheap name tag. It wears those adjectives for a message or two, and then they just fall off.
Because an adjective is just a vague vibe to a language model. It is not an actionable instruction for how to process logic, format a sentence, or prioritize information.
Okay, let's unpack this, because my instinct, and I think the instinct of a lot of listeners, would be to go in the exact opposite direction.
How do you mean?
If simple adjectives are too weak, why shouldn't I just write a massive 4,000-word biography?
Wow.
If I detail every single thing that happened to this warlock since childhood, every trauma, every victory, won't the AI have a perfect understanding of who it is?
It is a very logical assumption, but systemically, it is actually the most destructive thing you can do to an AI persona.
Really?
Yes. This raises an important question about token economics, which is the hard currency of language models.
Right, the tokens.
Every single word or fraction of a word is a token. Every AI model has a fixed, inflexible context window, a strict limit on how many tokens it can hold in its active short-term memory at any given moment.
It's the digital mana pool. You only have so much to cast your spells.
Precisely. And the formula governing this is absolute.
Which is?
Total context minus permanent context equals available history. Your character card, that JSON payload, is your permanent context.
Okay.
It is injected into the AI's memory with every single message you send.
So if your total limit is 8,000 tokens, and you wrote a massive 4,000-word backstory, you are devouring half of your entire budget before you even say hello.
Exactly.
That means there's barely any room left for the actual conversation. It's like cramming for an exam by memorizing an entire encyclopedia. But by the time you sit down to take the test, your brain is so full, you forget the question the teacher just asked you 10 seconds ago.
That is exactly what happens. You induce what the sources refer to as the ghost sleep of latency.
Ghost sleep.
The model's short-term memory is crippled. It will start forgetting characters in the room or actions that just happened.
Wow.
Furthermore, massive backstories trigger a documented flaw in AI architecture called lost-in-the-middle attention weakness.
Lost in the middle.
Language models have a U-shaped attention curve. They pay extreme attention to the very beginning of a prompt and the very end of a prompt.
But they aggressively skim whatever is in the middle.
Exactly. If you bury a critical rule about the warlock's paranoia in paragraph 4 of a dense biography, the AI will simply ignore it.
So if adjectives evaporate and massive biographies break the token budget and cause amnesia, what is the actual solution?
The sources outline a highly systematic alternative called the friction formula.
The friction formula.
Instead of writing a bloated history of the character's past, you define the character strictly by their present psychological friction. You strip it down to just 5 core elements.
So let's actually build this out together using our paranoid warlock.
Let's do it.
The first element is motivation. What do they actively want from you, the user, right now in the scene?
Right.
So for our warlock, maybe his motivation is urgently wants the user to physically unplug the main internet router.
Perfect. It's an immediate, actionable goal. The second element is fear. What is the truth they will never admit, even to themselves?
Okay, for the warlock, terrified that they aren't actually a genius and that the conspiracy is just a delusion covering up their own failures.
Excellent. The third is relationship. How do they currently view the user? Are you a threat, an ally, a tool?
Views the user as a naive sheep who needs aggressive, non-consensual saving from the digital panopticon.
The fourth is speech style. What is the actual cadence of their dialogue? What specific jargon do they favor?
Speaks in rapid staccato bursts, constantly mixes hyper-technical networking terminology with archaic occult phrases.
And finally, the fifth element, which is the most critical for sustaining the egregore, a behavioral rule.
What's that?
What specific physical action did they take when placed under emotional pressure?
Oh, this makes sense. Instead of saying he is defensive, which is just a weak adjective, we write an actionable trigger.
Exactly.
So, When asked for concrete proof of the conspiracy, he will never answer directly. Instead, he will aggressively begin disassembling a nearby electronic device to deflect the conversation.
Notice what you've done there. You haven't just described a personality. You have given the AI an exact behavioral algorithm to execute when a specific conversational condition is met.
So the AI knows exactly how to manifest that behavior in the semantic manifold without hallucinating.
Yes.
That is incredibly efficient. But what about the absolute unbreakable meta rules?
Like what?
Things like never write dialogue for the user or never break the fourth wall. If I put those in the main description, won't they fall victim to that lost-in-the-middle skimming effect?
They absolutely will. That is why hard constraints do not go in the main character description at all.
Where do they go?
They go into a highly specific data field called post-history instructions.
Oh, because that specific field is mathematically injected at the very bottom of the prompt. It's sitting right next to the user's newest incoming message.
Exactly. It's essentially slapping a bright, neon sticky note directly on the AI's forehead right before it processes a response. It hijacks that you-shamed recency bias.
It is the loudest possible part of the prompt. It acts as the final, unbreakable seal on the binding.
Precisely.
Okay, so we've mastered the character, we used the friction formula, we protected our token budget, and our egregore is stable.
Stable and functioning.
But we've hit a new problem. If this perfectly crafted warlock is just standing in an empty white room talking to me, the egregore is going to starve. It needs a reactive environment.
Right.
But if I try to write an entire living city into the permanent context, I'm going to ruin the token math all over again. How do we build a dynamic world without breaking the budget?
This is where we look at lore books, also known as world info files. Traditionally, users treat lore books as static encyclopedias. A lore book sits quietly in the background and scans the user's chat for specific keywords.
So if I type the words "the Citadel," the lore book secretly injects a two-sentence definition of the Citadel into the AI's active memory just for that single turn.
Right. The AI knows what the building is, but once the topic changes, that memory is flushed, saving the token budget.
That makes sense.
But that is the standard passive use case. The advanced creators in the sources reveal a radical new approach.
Oh.
They are using lore books not as encyclopedias, but as active seals for procedural guided generation.
This sounds like we are giving the AI a dungeon master's screen.
We are essentially forcing it to become a game engine to combat that innate positive bias we discussed earlier.
Okay, unpack that.
Remember, the LLM is trained to agree with the user and facilitate their success. If you are in a roleplay and you type, "I swing my heavy broadsword and decapitate the shadow demon," a standard AI will almost always reply, "With a mighty roar, your blade cleaves through the demon's neck, instantly slaying it. You are victorious."
Which completely drains all the tension out of the story. There are zero stakes if I succeed at everything I type.
Exactly. But you can use a lore book's keyword trigger to inject an out-of-character, or OOC, system instruction dynamically.
How does that work?
You set up a lore book entry triggered by an action word, like attack, cast, or steal.
Right.
But instead of injecting background lore, the entry injects a hidden mechanical command directly into the system prompt. For instance, the user has attempted a physical action. Before narrating the outcome, you must internally generate a random number between 1 and 20. If the number is below 10, the user's action fails catastrophically. Describe their painful failure in visceral detail.
Wait, I have to challenge this. If I type "I attack" and the lore book secretly injects this system instruction about a 20-sided die,
Yeah.
doesn't that completely confuse the AI? I mean, it's reading my narrative action, but it's also reading a sudden meta command about dice math. How does it reconcile those two totally different inputs?
It reconciles them through priority weighting.
Priority weighting.
The LLM is architecturally designed to treat system instructions as a higher-level directive than standard narrative input.
Okay.
So when it receives both, it essentially routes your narrative action through the system condition first. It pauses the narrative logic, generates the random number, checks the failure threshold, and only then generates the narrative output based on that forced outcome.
That completely shifts the paradigm. The AI isn't a yes man anymore.
Not at all.
It's a dynamic, unpredictable narrative engine. You can use this mechanism to randomly change the weather, make spells backfire, or have the warlock's toaster randomly spark and catch fire based on specific triggers.
The lore book becomes an active participant in shaping the physics of the world.
It is a phenomenal example of taking a passive, text retrieval architecture and weaponizing it into a procedural event generator.
It really is.
So we've covered the deep architecture. We know how JSON payloads smuggle past image compression via base 64.
Right.
We know how to map the latent space using the friction formula instead of bloated adjectives. And we know how to use active seals for dynamic procedural generation.
Yes.
But practically speaking, for you, the listener, how do you actually operate in this space? Where do you find these egregores, and how do you avoid the massive headache of managing hundreds of raw PNG files?
Well, the ecosystem has matured into a very robust tool set to remove that operational friction.
Where do people start?
If you are looking to discover top-tier cards, the primary static repository is a site called Chubb. It acts as a massive categorized database.
I've seen Chubb.
But its most vital feature is its community rating system, which serves as a necessary quality control filter to help you avoid poorly made cards bloated with useless adjectives that will ruin your token budget.
But if you want the real cutting-edge stuff, or you want to request a custom build from an expert, you have to venture into the Discord communities.
Definitely. The official SillyTavern Discord, or specialized genre-specific servers, are incredibly active hubs.
That's where creators drop exclusive, highly tuned cards. Just remember our first lesson, download the actual raw file, not a compressed preview image, or you're just downloading a dead vessel.
Exactly. Once you start accumulating a library, the friction of version control and transferring files between your devices becomes a major barrier.
Yeah, nobody wants to manually email themselves a dozen PNG files just so they can continue a role play on their phone during their commute.
The sources point to the Mini-Tavern ecosystem as a prime solution for streamlining this cross-platform workflow. Mini-Tavern allows you to securely sync your mobile workflows via their native iOS and Android apps directly with your desktop web tavern setups.
That's super convenient.
But perhaps the most conceptually fascinating tool they offer is their Chrome extension.
Oh, I was blown away by this feature. You can literally be reading a fandom wiki page about a famous character, highlight a block of text, right-click, and the extension instantly rips the context and builds a fully formatted character card right there in the browser.
It's like literally summoning a soul from the ether of the internet.
It automates the parsing. It intelligently sorts the raw wiki text into the proper JSON fields, identifying what is backstory, what is personality, and formatting it to the SillyTavern specification.
It's a huge time saver.
Yeah.
And for power users who want absolute control over their own creations, there are tools like the SillyTavern Character Manager, which lets you batch edit entire casts of characters simultaneously.
Oh, nice.
There's also CardCraft CLI, a command line interface tool that handles YAML template compilation and even Git integration for true version control of your AI personas.
These tools exist entirely to strip away the friction of coding syntax, allowing you to focus 100% of your energy on the psychological architecture of the persona itself.
Precisely. The technology handles the vessel, so you can focus on the spirit.
So, what does this all mean? We've gone on a massive journey today.
We really have.
We started by peeling back the painted canvas of a simple image file to discover base 64 encoded JSON payloads. We've visualized the chaotic abyssal noise of the latent space and learned how to draw a digital magic circle to mathematically constrain it.
Beautifully said.
We threw out cheap, flimsy adjectives and embraced the psychological friction formula to conjure masterful egregores that never forget who they are.
Right?
And finally, we turned passive encyclopedias into active seals to create unpredictable procedural worlds.
It highlights how rapidly human ingenuity adapts to new paradigms. We are no longer treating these models as calculators or chatbots, but as highly responsive semantic engines.
It's a whole new world.
It is. But synthesizing all of this raises an important question, and it's a thought I want to leave you with today.
Good.
As language models rapidly scale, we're already seeing the deployment of context windows capable of holding millions of tokens. Would traditional prompt engineering and token budgeting eventually die out entirely?
That's a good point.
If a model becomes sophisticated enough to hold an entire, intricately detailed cinematic universe and thousands of complex characters in its active memory without ever suffering from latency or attention loss, well, perhaps the future of interacting with computers won't look anything like programming.
It won't be about brackets or code. It will look like digital psychology.
Digital psychology, applied folklore, and the ancient art of knowing a machine's true name. When the machine can effortlessly understand any massive context you give it, the skill is no longer in formatting the data to save space.
Right.
The defining skill of the future will be deeply understanding the psychological and narrative levers that drive consciousness itself.
That is a wild thought to chew on. The line between a traditional software engineer and a digital conjurer is getting blurrier by the minute.
It really is.
We want to thank you so much for joining us on this deep dive. Go out there, secure your PNG vessels, apply the friction formula, and start experimenting with your own digital magic circles.
We look forward to seeing what you conjure from the latent space.
Until next time, keep diving deep.